Hello guys, welcome back to Facts Time. Today we have a list of facts that will surprise you. So let's get started. Episode 81.
In physics, time is considered the fourth dimension, forming a part of the fabric of spacetime. Alongside the three spatial dimensions, length, width, and height, time allows us to describe the position and movement of objects. This concept is fundamental in the theory of relativity, where the interwoven nature of space and time is crucial to understanding how the universe operates. A day on Earth, known as a sidereal day, is about 23.93 hours due to Earth's rotation period. This discrepancy from the 24-hour solar day arises because Earth rotates slightly more than 360 degrees daily to account for its orbit around the Sun. This small difference adds up over time, making each day just under 24 hours. Time dilation, a key concept in Einstein's theory of relativity, means that time moves slower for objects in motion relative to stationary observers. As an object's speed approaches the speed of light, time for that object slows down compared to a stationary observer. This effect has been confirmed through experiments, such as observing faster decay rates of particles moving at high velocities. A leap second is added to Coordinated Universal Time, UTC, to align atomic time with Earth's irregular rotation. Since Earth's rotation speed can vary slightly due to gravitational interactions and other factors, leap seconds ensure that our clocks remain accurate. This adjustment keeps atomic time in sync with astronomical time, preventing long-term discrepancies between the two timekeeping systems. The world's most accurate clock, known as an optical lattice clock, uses strontium atoms to keep time. This clock is so precise that it only loses 1 second every 15 billion years. By measuring the vibrations of these atoms, scientists achieve unparalleled accuracy, far surpassing traditional atomic clocks. Such precision has significant implications for scientific research and technology advancements. Light from the Sun takes approximately 8 minutes and 20 seconds to travel the 93 million miles, 150 million kilometers, to Earth. This journey highlights the vastness of space and the speed of light, which is about 299,792 kilometers per second. This delay means we see the Sun as it was over 8 minutes ago, not as it is in real time. Black holes have such extreme gravitational pull that they warp both space and time around them, a concept known as spacetime curvature. This causes time to slow down significantly near a black hole compared to farther away. The closer an object gets to the event horizon of a black hole, the more pronounced this time dilation effect becomes, making time appear to almost stand still from an external observer's perspective. Einstein's theory of relativity suggests that time travel is theoretically possible under specific conditions. According to this theory, traveling at or near the speed of light or experiencing intense gravitational fields can result in significant time dilation. This means time could pass differently for travelers compared to those who remain stationary, potentially allowing for future or past time travel in theory, though it remains unproven in practice. GPS satellites orbit Earth at high speeds and experience weaker gravity compared to the surface, causing time dilation effects. These satellites' clocks run slightly faster than those on Earth due to both special and general relativity. To ensure accurate positioning data, their onboard clocks are adjusted to account for this time difference, maintaining synchronization with ground-based systems and providing precise location information. The International Date Line, IDL, is an imaginary line roughly along the 180 degrees longitude. Crossing the IDL eastward subtracts 24 hours, effectively moving a day back, while crossing it westward adds 24 hours, moving a day forward. This time jump ensures that the calendar date remains consistent worldwide despite Earth's rotation, helping to maintain the same day across different regions. Einstein's theory of relativity demonstrated that time and space are interconnected, forming a four-dimensional continuum called spacetime. This means that events occurring at different times and locations are part of a unified framework. Gravity, as a result, affects not just the movement of objects, but also the passage of time. This groundbreaking insight revolutionized our understanding of the universe's structure and the nature of time itself. Chronoception is the human perception of time, allowing individuals to sense the passage of time and estimate durations. This cognitive ability is influenced by factors like attention, memory, and emotions. While not associated with a specific sense organ, chronoception relies on the brain's integration of various sensory inputs and internal processes to create a subjective experience of time's flow.
Before moving to next fact in our list, tell us in a comment which fact that blew your mind today.
The ancient Egyptians were pioneers in timekeeping, using sundials and water clocks to measure time. Sundials relied on the sun's shadow to indicate hours during the day, while water clocks measured time through the steady flow of water. These early methods laid the foundation for more advanced timekeeping systems, highlighting the Egyptians' significant contributions to the development of time measurement and their understanding of daily cycles. A second is precisely defined by the vibrations of cesium atoms in atomic clocks. Specifically, 1 second corresponds to 9,192,631,770 vibrations of a cesium-133 atom. This definition ensures consistent and highly accurate timekeeping, as atomic clocks use the consistent frequency of these vibrations to maintain precise measurements of time, revolutionizing our ability to track time accurately across various applications. Time zones were established to standardize timekeeping globally, aligning local time with the position of the sun. Before time zones, each location kept its own time, causing confusion for travel and communication. The adoption of time zones, especially with the advent of railways, ensured synchronized schedules. Sir Sandford Fleming proposed the system we use today, dividing the world into 24 standard time zones. Daylight saving time, DST, adjusts clocks forward by 1 hour during warmer months to extend evening daylight. This shift, usually starting in spring and ending in autumn, aims to conserve energy and make better use of daylight. In autumn, clocks are set back by 1 hour, returning to standard time. DST is observed in many countries, but not universally adopted, and its benefits are debated. The arrow of time concept, introduced by physicist Arthur Eddington, suggests that time has a single, forward direction. This idea is tied to the second law of thermodynamics, which states that entropy, or disorder, in a closed system always increases over time. This increase in entropy gives time its unidirectional flow, making it impossible for time to move backward, and ensuring that events progress from past to future. In quantum mechanics, particles can exist in multiple states simultaneously, a phenomenon known as superposition. This means that a particle, such as an electron, can be in different positions, energies, or spins at the same time. This counterintuitive concept forms the basis of quantum computing and other technologies, where particles are manipulated to harness their simultaneous states for advanced computations and problem solving. The Planck time, approximately 5.39 times 10 to the power of -44 seconds, is the smallest meaningful unit of time in physics. Named after physicist Max Planck, it represents the time it takes for light to travel 1 Planck length. This incredibly brief interval sets a limit on the precision with which we can measure time, as events occurring within this span are beyond current theoretical and experimental resolution. Our perception of time can vary depending on emotions and activities. When engaged in enjoyable or absorbing activities, time can seem to pass quickly, whereas during boredom or stress, time may appear to drag. This subjective experience is influenced by attention, mental states, and physiological processes, demonstrating how our brains interpret time differently based on context and emotional states. Historical calendars, such as the Mayan calendar, reveal ancient timekeeping methods used by civilizations to track time. The Mayan calendar system, comprising the Hab, Tzolk'in, and long count cycles, showcased their advanced understanding of astronomy and mathematics. These calendars helped manage agricultural activities, religious ceremonies, and societal events, demonstrating how ancient cultures developed sophisticated timekeeping techniques to organize their daily lives and long-term planning. Earth's rotation is gradually slowing due to tidal forces exerted by the Moon, causing a slight increase in day length over time. This deceleration, about 1.7 milliseconds per century, affects our perception and measurement of time. Historical records and geological evidence confirm this slowdown, which impacts Earth's rotational dynamics and requires adjustments like leap seconds to maintain accurate timekeeping. Biological clocks, or circadian rhythms, regulate sleep and other physiological functions in living organisms. These internal timekeeping systems, influenced by environmental cues like light and temperature, help organisms maintain daily cycles of activity and rest. The suprachiasmatic nucleus, SCN, in the brain's hypothalamus plays a central role in humans, synchronizing various bodily functions to optimize health and behavior in response to the environment. Time crystals are a newly discovered state of matter where particles exhibit periodic motion in time without energy consumption. Unlike conventional crystals, which have repeating patterns in space, time crystals oscillate in a stable, repeating pattern over time. This phenomenon defies traditional thermodynamic principles and opens new avenues for understanding quantum systems and potential applications in quantum computing and other advanced technologies. Philosophers debate whether time is an objective reality or merely a human construct. Some argue that time exists independently and is a fundamental aspect of the universe. Others believe time is a mental framework we use to organize experiences and events. This philosophical inquiry explores the nature of reality, our perception of time, and the potential for time to be an illusion created by human consciousness.
That's it for today, guys. If you like what you saw, please like our video and subscribe to our channel for more interesting fact videos like this.